So now, thank you very much. Now to present the final team of the day before the quick pitch starts after this. So many things to happen. Our final team, Odyssey Sensors from the UK.
Good evening, ladies and gentlemen. My name is Kevin Baum, and this is Stephen Honan, and we're going to talk to you about Odyssey Sensors, which is a social enterprise that's aimed at developing technology for low-income farmers with the aim of both increasing their profitability but also mitigating some of their environmental impact.
To begin, I'd like to tell you about our approach. We actually go into the country and interview farmers and listen to their needs. Our first product began when I lived in Bangladesh for 9 months, and I traveled around the country and interviewed farmers and listened to what their daily challenges were. I shadowed their day-to-day schedules and learned what kind of difficulties they faced. And what I found was actually that in the southern coast, Bangladesh is grappling with saltwater intrusion as a consequence of the sea level rising and global climate change. As a result, the farmers are actually having to shift away from traditional forms of agriculture, such as the staple crop of rice, and actually have to deal with this brackish water which is coming in and affecting their crops. So as a result, they're actually switching over to shrimp aquaculture. And this is in the southern region. In a 1 acre lot, a plot of land, they're actually able to grow enough shrimp to earn a living wage. It's very meager, but it's a living wage. And the difficulty is actually that they have widely fluctuating yields. So in one farm cycle, they might have 100 kilograms of shrimp, and then the next they might have 300. And most of that variation actually comes from the water quality, and more specifically, the salinity levels. So if you look at the survival rates of shrimp, you can see that if you maintain the optimal level of 25 parts per thousand, you achieve the highest yield possible. But if you drop outside of that range, the shrimp are very sensitive to that, even in a short period of time. So the farmers are actually cognizant of this, and they go out and test their ponds. But their current technique is to just dip their finger in the water, lick it, and say, "Is it salty enough? No. All right, I'll put some more salt in the pond to make it in that optimal range." And when you look at it from a price perspective, it's better to be on the saltier side than it is to be on the freshwater side. And this is where the trade-off between the environmental damage and the economic return comes into play. And also it actually dips into their actual return on investment, because you can see that they're actually only accruing roughly $300 a year. So these farmers are struggling to survive, and the difficulty is that they can't really compete with the commercial plots, which have access to real technology to provide that feedback, that saltwater concentration. And when we looked at this, it's pretty shocking, but the reason that these salt sensors are so expensive is because they can test for a wide range of salt content. So they can test the fresh water that you drink as well as the seawater out in the ocean. And the predominant technique is actually to drive an alternating current through the water. It interacts with the salt, and then they actually measure the resultant waveform. And that process is pretty component intensive, and what we did as Odyssey Sensors was redesign a sensor specifically for this application, and that's exactly what we did. So we distilled it down and thought, okay, if we focus the solution just on the range of the salinity levels that are most applicable to the shrimp farming, then we're actually going to be able to provide a usable result to these individuals, and that's where we actually were able to design our own technique. We have our own probe. It's a patent pending, and additionally we're able to simulate that alternating current with just a microprocessor, and it's optimized specifically for this application of shrimp farming.
So after making the product, we took it through a series of rigorous lab tests, and we tested it against a scientific sensor that cost about $1,600. And as you can see from our results, functionally within the range that's optimal for shrimp production, it gave us the results that they would need in order to optimize what they were doing. So what we end up getting is a sensor that we can manufacture locally. We designed it so it could be locally manufactured, and it costs us about, the original one was made for about $5.50, but with economies of scale, we think we can get manufacturing down to about $3.50. And this fits well within the ability of these farmers, ability to pay, and particularly given the fact that it will be helping them improve their incomes in the long term. But having a sensor that works isn't enough. We know that when introducing technology to places, you need to make sure that it's something that can be easily used and there's a low learning curve. And so what we did is we actually made the output a very simple series of symbols that recommends to the farmer what corrective measures need to be taken in order to optimize concentration. So there's a bank of LEDs that lights up when you stick the sensor in the water, and based on that you can do multiple iterations until you get the salinity concentration where it needs to be.
So when you look at the supply chain, you have to realize, how can we actually get this product in the hands of the people who need it the most? And we mapped out the value chain of how the shrimp go from being born to being exported. And when you look at it specifically in Bangladesh, the hatcheries are in the southeast coast of Cox's Bazar. Those eggs are then shipped up to a central distribution point of Khulna, and then actually distributed out to farming clusters across the southern coast. And those farming clusters were actually formed by the UNFAO as a means to create a level playing field with the small plot farmers against the commercial plots. So they're able to aggregate the farmers and mitigate against the risk of one farmer having a low production and the other one having high production. And so once they actually get to the farming clusters, they are distributed out to the individual farms, cultivated, reclustered, and then they're actually ready for export. So when we evaluated where the Odyssey Sensors Healthy Shrimp sensor actually fits into this value chain, we approached the hatcheries, and there are about 175 of them along the Cox's Bazar coast. And we sat down and discussed how we could bundle together a salinity sensor with the eggs that would then get distributed to the actual farming clusters and subsequently the farmers in hand. And the hatchery owners were actually very excited to work with us because we were able to deliver a product that has a higher survival rate, and so they're eager to work with us as a private partnership. We have three main metrics. We're able to increase the livelihood and decrease the salt content as an environmental risk, and we're able to measure that through the farming clusters. And the market is 1 million farmers in Asia, and actually 90% of the shrimp is actually cultivated in Asia for the worldwide market.
So after hearing about the success of the sensor, we were approached by Solidaridad, which is an organization that works in Southeast Asia on agricultural development. Solidaridad is a Dutch organization, and the Netherlands is another low-lying country that battles with similar issues of saltwater intrusion into arable land. And they requested that we consider a method of using the salinity sensor as an advanced logging environmental monitor, looking at saltwater issues in the world. And as a company, we have a suite of products, one of which is generated us our initial revenue and has over 500 orders pending, which is a remote trough sensor for livestock agriculture. And in order to make this work, we needed to create a very low-cost mesh communication network that would transmit signals in very rural areas and transmit it across long distances. And so going forward, what we want to do is leverage this communication network that we've created and combine it with our salinity sensor to create a low-cost solution for high-resolution environmental monitoring, looking at rising sea levels and the consequences that may have to give us better ability to battle the issues from that. We have a great team that we've put together to solve this, ranging from some phenomenal engineers and then some entrepreneurs who have worked on developing world businesses and nonprofits. And this is a great team to continue to innovate as we continue to battle different challenges like this across the globe. And recently, we've brought in a new member to our team who has 25 years developing startup businesses, and he sold his most recent one for 225 million pounds. So he knows a lot about how we can scale this product and how we can really increase our impact worldwide. And so right now our goal is we're ready to go and get a round of funding, which we want to secure at some point later this year, so that we can build up our manufacturing ability and really start to get our impact out there. Thank you.